Okay, so here we have the graph showing the monthly cost of electricity supplied by Sparklight. So the vertical axis, now I take note, I didn't say it is the y-axis, it is called the vertical axis representing the cost. Horizontal axis will be the units of electricity. So the more electricity you use, what do you expect to happen? The higher the cost, okay, the more money paid, save. And that makes sense. In this particular graph, can you tell me the cost if the person uses no electricity? For example, the person went overseas, not at home for 1 month, how much does she have to pay? According to this graph. 60? 16. Oh, 16. Okay. So each little square represents $4, right? Okay, so $16. That's correct. In Singapore, we use all our electricity used to be supplied by Singapore Power. Probably a few years ago. Then they opened up the electricity market, and now we have a lot of suppliers for electricity. Sunseed, I think Keppel, so on and so forth. Go and check your parents if they have actually switched. By default, it is Singapore Power. They charge the highest. That's the default. If your parents didn't switch, that means you're paying extra money for no good reason. So if you want to switch to any plan, any of them, it will be cheaper than the default, which is Singapore Power. So please ask your parents to go and switch. If they need a referral code, you can look for other people. Then they will have discounts here and there. So now, find out the amount that he was charged. Based on this graph, for 700 units, just draw a line up and read off, we get about $134. Okay, according to the graph. Okay, next, Power Save. Okay, this is another supplier. Basic fee of $60 per month. So the basic fee is the amount that you have to pay regardless of whether you use any or not. Comparing this $60 versus the original over here, 16. Yes? What? 132. Confirm, 5A. Okay, let me see. So 700 units. Okay, so you see the 700. So at this mark, right? Do you have that? Is it in between? Is it in between one tiny square? Yes or no? Yes, right? Okay, let's draw a line across. It is over here. Do you agree? Okay, so let me count. Every little square is 4 units. So 124, 128, 132, 134. Okay, now on your graph, this is after I zoom in. Do you agree that this is the point where it cuts the graph? This has a value of 700. Look at your graph, is it true? And then you draw a horizontal line. Hey, it is right in the middle. Draw a horizontal line across and we reach this point. This is the value that I want. Okay, so now I'm going to start counting. This is 1, 2, 4, 1, 2, 8, 1, 3, 2. This is 1, 3, 2. And the next little box will be 1, 3, 6. Between 1, 3, 2 and 1, 3, 6 will have to be 1, 3, 4. Okay, read carefully. Okay, so PowerSafe charging $60 per month. We know that if they use 0 units of electricity, it is going to cost $60 already. Sounds like a really horrible deal, isn't it? Without doing anything, it's going to cost $60. Later we're going to have to plot. So can you check, do you have this point over here? You at least need 2 points to draw a graph, right? And we want 3 because we are kiasu. We want to check. Alright, so next, they say that it costs $0.112 per unit of electricity used. Draw a line to represent the cost. Okay, so we can draw a table and we write down the values, right? For different amounts of unit, what is the cost? Let's be smart about it. Which value over here would you choose to substitute in to draw a straight line? Remember, we always want the starting and we want the ending. So let's find out how much it costs if I use 1000 units of energy. Okay, so for 1000, the cost is going to be 600. Sorry, not 600, 60. That's the original, plus 1000 times of 0. How much did they say it costs? 112. So this is the cost right at the end. And it gives me 0.112 times 1000 plus 60. $172. I'm going to find for 1000 units, it costs 172. So again, we have to be really careful. 160. Now 172 is 8 less than 180, so it is going to be 172 over here. Now line across. Okay? And 2 points by right is good enough for me to draw a straight line. But because I want to be really sure, I'm going to choose 1 point in between. What point would you like? If you have used 0 and 1000, what would you like to use? 600? Okay, let's try 600. You can go with 500 also. So if it is 600 units, 600 and we plus 60. Ends up it is 127.2. Now 127.2, you have to think about it. It's your, over here, are you able to tell where 127.2 is? No, right? We only have multiples of 4. So while it is not wrong to substitute in 600 over here to find out the cost, it is not very helpful in our plotting 127.2. Not too helpful because I cannot pinpoint exactly 127.2 on the vertical axis. Let's try another value. Yeah, I think I will go with 500 also because 500 is right in the middle. Let's try that. 500 times 0.112 plus 60. This gives me 116. And this is going to be a multiple of 4. So 116 is actually 4 less than 120. So this is my 116. And I identify where 500 is. 1, 2, 3, 4, 5. This is my plot. Okay, then after that, take a ruler. By now, you should be hoping that they all lie on a straight line. And they do. So once you see that all 3 points lie on the same line, you can be sure that, you can be very, very sure that your plots are correct. So join them up with a straight line. And we must label. What is this graph for? This is for power save, right? Okay, so this over here 2 marks. 1 mark for the plots, another 1 mark for the line. So this Mr. Lim is changing, thinking of changing to power save. Is it a good idea to change to power save? That's the question. I mean, that's my question to you. Based on these 2 graphs, would you recommend that he change to power save? The answer is, I cannot decide yet because it depends on how much he uses a month. If he uses, let's say, 200. If he uses 200 units per month, over here, if he uses 200 units per month, what is the cheaper option? So we go up from 200, we go up. Oh, Spark Life is going to cost this amount. and power save is going to cost, wow, higher. So if he uses 200, Spark Life is a better deal. Then suppose he doesn't use 200, if he uses, let's say, 400, then we continue. Spark Life, Spark Life costs this amount, whereas power save costs more. So Spark Life is still better. And we can keep doing this comparison until we reach a certain point where it doesn't matter. At which point does power save and Spark Life cost the same? At which point do they cost the same? What are we looking for on the graph? Now where they intersect each other. Because where they intersect shows the same value of cost. Can you identify that on your graph? So for me, this works out to be this value, 1 square before 800. So every small square represents 20 units. 2, 4, 6, 8, 700, 2, 4, 6, 8. So for me it is 780. When 780 units of electricity is used, the cost is the same. Okay, that's my intersection point. So once it goes past 780 units of electricity, we see that power save actually will cost cheaper as long as it is more than 780 units. So this value will be 780. Okay, it is important that you understand what is happening over here and how we interpret the graph. That is the key skill that we need you to have for our Sec 1 syllabus. Any questions? Okay, next page. Okay, solid trapezoidal prism. Okay, so this just means trapezium. With a cylindrical hole drilled through it. So the radius is 3 cm, so and so forth, all the information given. Find the total surface area of the solid. Find the total surface area of the solid. Total surface area includes all the ones on the outside as well as in the hollow. So we need to include that also. Okay? Now, regardless of whether we are finding surface area or whether we are finding volume, regardless of which one, we will require the cross-sectional area, which they very kindly shaded for us already. So let us find cross-sectional area. So give me statements so that I know what you're calculating. If it is just numbers added and multiplied together, I will not understand. The marker, who may not be me, may not understand what you're doing and you may be penalized. So to get the shaded area, we need the area for 2 shapes. Which shapes do we require? Which areas do we require for the cross-sectional area? Trapezium. Okay, what else? Circle. Daniel, what should we do with the area of the circle and the area of the trapezium? Which one minus which one? Okay, good. So area of the trapezium, half times Zheng Jie, half times what? For the area of the trapezium. (14 plus 8). So it is known as the sum of parallel sides multiplied by how much? 10. Just realized there's a problem. Do you notice a problem? Do you notice there's a problem in the diagram? Nobody? Anybody can identify the problem? I will give you a prize next lesson. Food lah, food. Yes, Sudhir? Huh? The radius is 3 cm. So what's the problem? 3 cm plus 2 cm. Where did 2 cm come from? Hmm? Oh, 3 plus 3. Okay, 3 plus 3 is 6. So? This is 6 and this is 10. What's the problem? Is that a problem? Okay, who wants to try? Who wants to try? Come on, raise our hand. Nobody? We raise our hand, otherwise I can't tell who wants to answer. Okay, yes, Rian? You're telling me that this cannot be 5 cm? Is that what you're saying, Rian? Okay, what's your reason? Oh, no reason, not counted. Okay, Aloysius raise his hand first. Yes? Do you understand what he's saying? No. Okay, Yishuan? Yishuan says that the side, GB, right, should be longer than which one? She says that this should be longer than 10 cm. Okay, why? Okay, she says that if this is 10 cm, then the diagonal, this GB must be more than 10 cm. Now, this over here is a triangle, right? Can we have the longest side? This is 90 degrees, huh? Can we have the longest side, which is opposite the largest angle, which is 90 degrees in this case, to be smaller than 10 cm? Are you able to construct a triangle, a right angle triangle, with the longest side, which is opposite the 90 degrees, to be shorter than this perpendicular height? We cannot. Okay? So thank you for your efforts. Who are those who tried? Siting, Yishuan, Aloysius, Brienne, and Omera also tried, right? 1, 2, 3, 4, 5. Okay, I'll bring 5 items or something next lesson. Okay, so I understand that all of you probably would have just used the 5 cm for your subsequent calculation, right? So I'm not going to make you redo your work, but just have an appreciation for the numbers here, can? Know that this diagram is not possible. A more reasonable number probably will be 15, 12, okay, yeah, reasonable numbers. As long as more than 10. Okay, now, so cross-sectional area, half times sum of parallel sides times the perpendicular height minus pi r squared. Huh? Oh, they asked us to use 3.142, okay. So minus 3.142. And we should be able to get an exact value for this, which is 5 times 22 minus 3.142 times 9. 81.722 square cm. Okay, this is the cross-sectional area, and I know that subsequently I will be using this value for the surface area and the volume. So let's start with the cross-sectional, the total surface area. Total area is given by 2 times of this cross-sectional area. There are 2 of them, one in front and one at the back. 2 times of 81.722, and I need to add something. We add the perimeter. So this is where we have to be really careful to trace out the perimeter of the cross-sectional area. This is a 5. So 5 plus 14 plus another 5, and keeping in mind that actually it shouldn't be 5, it should be something way longer than that. And plus 8. Is that all? If I take the red color perimeter, I multiply it by 12. I'll be painting all this red, isn't it? What about the inside? Is it also a surface area? Yes, it is. Therefore, I still need to add this perimeter. It has a special name, it is called a circumference. So add 2 pi r. Okay, now I have the perimeter of the cross-sectional area. But I need to multiply this by the perpendicular height, which is 12 over here. Okay, work this out. Seven 3.668 square centimeters. Do we need round off? Think. Do we need round off? Who says need to round off? Who said no need round off? What's the reason that we don't need round off? This is exact already. They told us to take 3.142. But if they left out this part, then we need to round off, okay? If they left out this part, then your answer over here is, it's not going to be exactly like this. We got this based on 3.142 in both of these areas. If they didn't say 3.142, we use our calculator value of pi. We're going to get a slightly different answer, and then we need to round it off to 3SF because it is not exact. In this particular case, since they wanted us to take pi to be this value, I need to leave it as it is. And now finally, the volume of the prism. Volume is going to be the same cross-sectional area. That's why this is very useful for us. 81.722, and we just multiply it by 12. This is more straightforward. (980.664 cubic centimeters). Okay, now in part B, they said that the solid is melted. So we're going to melt this thing and recast. That means change the shape into a cylindrical solid. In questions like this, there is no loss of material. That means the volume does not change. You understand what I'm saying? Volume does not change. So then it becomes a cylindrical solid, looking something like this. The height is 10 centimeters. And they want us to find the radius. So let this be r. Let radius be r cm. Okay, this is how I will do it. But I don't think everybody did it this way. Can I have a show of hands? How many of you thought along this way? You think that, okay, volume is this. The pi r square times the height is going to be this value. So if I want the radius, I need to take this, I need to divide by 10. Then I need to, because it's pi r square, then I need to divide by pi again, then I need to square root it. Who thinks this way? Confirm. Because that's how you taught in primary school, right? You work backwards this way. It is very tiring, especially when it comes to secondary school work. We are very lazy people. We use algebra to help us. There are only a few sets of skills that we need in our algebra to make this very manageable. Because once we say radius is r, guess what I'm going to write? Pi r square h. Okay, let's do the substitution already straight away. 3.142 times r square times 10 equals to 980.664. You see, the formula over here, we all know pi r square times the height. the base area times the height. This volume is given to us. I am not going to think, wow, because it is times 10, I need to divide by 10, because there's a times pi, I divide by pi, because there's a square, I square root it. That is very taxing on the mind. Once I can write down this, I'm going to use my algebra. Oh, something times r squared times this pi times r squared times 10 is this. I want to make r squared a subject. In other words, I want to remove 3.142. I want to remove 10 by dividing. Right? It is algebra. You are just dividing. R squared is going to be 980.664 divided by 3.142, and we're going to divide by 10. Now I put multiply by 10 over here because it is 3.142 times 10. The whole thing divided. Okay, you can separate this step if you want to. But right now I've got r squared equals to this. We can find out the value. Then it's going to be square root of this value. So 980.664 divided by 31.42, 31.21145. Put in more SF. Okay, now we're going to square root this to give us 5.58 6, 7, 5 SF over here. This is my radius. Now question, is this an exact value? No, because whenever we do a square root, most of the time we are going to get a non-exact value. Okay. So what do we round this off to? How many SF? 3. Okay, what's the 3 SF? Okay, good. So this is our radius. I need all of you to be able to appreciate writing down the formula in terms of the unknown and solving for the unknown instead of working backwards in primary school. Things are going to get more complicated. Okay, now question 7. 8 packs of large cylinders of milk. Strange, huh? Cylinders of milk. Never see before. You got see before? Cylinders of milk. Where? Look at a cylindrical packet. Huh? Milk what? Got man. I only see the cuboid one. Then up there like a pyramid like that. Oh, one. Okay lah. Got this kind of bottle, right? But this is not a cylinder, But this is not a cylinder. Okay. Part of it is a cylinder. Okay, this one is a cylinder. Anyway, this is the story over here. Each one of them has a radius of 20 centimeters. Can you imagine what's happening? Quite ridiculous, right? It is 30 cm. If the radius is 20 cm, where got this count? Okay, no mind. It's just for the story over here. Height 30 cm. Right now the dimensions of the smallest crate. Okay, so we're going to arrange them this way. Dimensions refers to the length, breadth, and height. So what is the length? Because they want the smallest, right? That means I don't want any extra. I want to minimize the extra space. That means they're all packed very closely together. In this way. Length equals to how much? 1, 2, 3, 4, 5, 6, 7, 8 times 20. We got 8 radiuses, radii over here. 160 cm. Okay, the breadth. That will be 1, 2, 3, 4. 4 times 20, 80 cm. And the height, 30 cm. So these are the dimensions. Find in liters the amount of milk one large cylinder can contain. So now we're not talking about the crate anymore, we're talking about just one cylinder with a radius of 20 cm and a height of 30 cm. So amount of milk. We are trying to find the volume over here. Pi, did they say pi? Oh, pi is 3.142 again. 3.142 times the radius, 20 square. So this is our cross-sectional area. And we multiply by the height, 30. Okay, so this is the amount of milk in cubic centimeters. But we need to find it in terms of liters. Can you remember your conversion? Cubic centimeters to liters, what is the conversion? Okay, divide by 1000, so 3.7704 liters. Do we need to round off? No need to round off. Now in part B, the milk is repacked because they realize it's quite ridiculous to have such big packets into smaller cylindrical containers. The height is still 30, but the radius is now x. Apparently the volume of one such container is this. Calculate the radius. Similar to the previous question, instead of working backwards, we're going to write down the formula. So 3.142 pi r square times 30 cm is equal to 5, 8, 9 and 1 over 8. So this is the volume. And now we're going to find x over here. So x value will be, we're going to combine everything together. 5, 8, 9 and 1 over 8 divided by 3.142 times 30 and square root everything. Divided by 3.142 divided by 30, take the square root answer, and we get exactly 2.5. Do you have an exact value of 2.5? Or is your value approximated? It should be exactly 2.5. Okay, so this is the radius. Now it's also very ridiculous, right? Yeah. What kind of okay, it's really very tiny. 5 cm is the diameter. Can you imagine holding 5 cm bottle? But it's 30 cm tall. It's like this tall. Okay. So that's our radius. Then find the minimum number of smaller containers needed to repack the same amount of milk, assuming the containers will refill to the rim. The same amount of milk. Are they talking about? Okay, they are talking about all 8 big containers. All 8 big containers, they're going to divide into little containers. Each little container will hold 589 and 1/3 cubic centimeters. And how many of these containers are required? So we need to do a division. Number of containers will be the total volume divided by the tiny volume. So the total volume will be 8 times of one big container. Did we find the volume of one big container? 37704. We're going to use the cubic centimeter version. 37704. 37704 divided by the volume for one tiny container. That was given to be 5, 8, 9 and 1 over 8. Before I key it into the calculator, do you hope that the answer is an integer? That means it is a whole number? You hope that it's a whole number, right? Could it be it's not a whole number? What if it is not a whole number? Do you know what to do? Is it round up or round down? Or it depends on the point something? Rounds up, even if it is 0.001, we still need to round up. Because minimum number of containers over here, that's what they need. So let's find out what the value is. Oh, it's an exact value. Okay, so we need 512 containers. Okay, now container, the cost of the material to produce a large container is 25 cents per square meter. And they want the cost for 8 large containers. To find 8 large containers, I need to find one of them. If I can find one of them, I'll multiply by 8. So to find the cost of one large container, I need to find the area for one large container. Area for one large container will be given by so this is the total surface area, 2 times of the cross-sectional area. So the cross-sectional area is actually a circle. So 2 times of 3.142 pi r, radius is 20 square. So this is just the top and bottom only. I still need to add the perimeter, which is 2 times 3.142 times the radius times the height. So this calculation will give me the area for one container. Okay, so far? Okay, imagine the next line is going to be area for 8 containers, right? But I'm super lazy. I'm going to change this to 8. And I'm going to multiply by 8. So now this is the area for 8 large containers. Okay, so this is the area. But it costs 25 cents per square meter. I've got square centimeter now. Do you want to change this 25 cents per square meter to square centimeter, or should we change this to square meter? Change this to square meter, right? Okay, what is the conversion? Conversion to square meters. Divide by how much? Divided by 100 and you square, because now we want square meters. This is the area in square meters, which works out to be, without using a calculator, it's just a jumping of 4 digits. 1, 2, 3, 4. 5.0272 square meters. So this is the area, and then to find the cost. 1 square meter, 25 cents. This amount of square meter will be times 25 cents. 272 times 25 cents. Giving me 125.68 cents. Okay? So, but remember that we mentioned we should always leave our answer to 2 decimal places. 2 decimal places, what is the reason behind it? Should I leave this as 2 decimal places like that? Because you remember, right, Mr. Wong said, oh, when it comes to money, you leave it in 2 decimal places. Eh? Money, 2 decimal places. So is this okay? Okay or not okay? You have to think about the reason. Why did I say that for money, we leave in 2 decimal places? The smallest is actually 1 cent. Right? That is why we say smallest, that is why we say for money 2 dp, but that is for dollars only. Because the smallest denomination is 1 cent. You cannot find 0.68 cents. So if you want to leave an answer in cents, you will round it off to 126 cents. Or you will round it off as $1.26. Okay, so either one of these will be accepted. So understand the reason behind why we are doing some things. Last question. Was this part of your homework? Question 8. Okay, so take out your graph. Can I borrow your graph? Thank you. Okay, so now As usual, find one value of t, and its value is 60. So with that, 1 mark, very good deal. And how we do this is, just copy down the equation. Y equals to -5, then you see x, you put a bracket, plus 80. The reason I want you to put a bracket is because sometimes the x value is negative. And if you do not put a bracket, you may accidentally leave the negative sign. Then now, since we have the bracket, we just copy down the value of x, which is 4. And we get -20 plus 80, which is 60. So now we are able to plot 1, 2, 3, 4, 5, 6 points in our graph. They wanted us to use this particular scale, 1 cm, 1 unit on x-axis. So on your x-axis, which is the horizontal axis, 1 cm, 1 unit. Check that you have labeled every 1 cm. Because that's what they want the scale to be. And the horizontal axis is in minutes. X is for minutes, Y is for temperature. Then they told us that, oh, there's a particular range for the x-axis. From 0 to 10. So from 0 to 10, nothing more, nothing less. They also tell us that 2 cm to 10 units on the vertical axis. So every 2 cm, I must see a dash, 10, dash, 20, so on and so forth. Okay? How high do we go? That depends on our graph. Go back to our graph, the table of values. When x is 0, is 80. As time passes, the temperature drops. The highest, the largest value of y is 80. So I definitely must have up to at least 80. You can go to 90, 100, doesn't matter. They didn't restrict you. But 80 will be enough. So make sure you adjust your axis until you have enough space for 80. So there are 1, 2, 3, 4, 5, 6 points. I will be checking 1, 2, 3, 4, 5, 6, and they all have to lie on the same line. So this will give us 2 marks. 1 mark for the points, 1 mark for the straight line. Oh, sorry, 3 marks, because 1 more mark for the scale. So this is a 3-mark graph. Next, find the gradient and explain the significance. There are 2 ways we can do this. One is the easier way, and one is the harder way. Both of which will give us the same answer. Do you know how to calculate the gradient? How many formula do you know? 2, rise over run. Now, choose 2 points, any point you like. I know students, they don't believe me, when I realize when I ask other students, they don't believe me when I say you can choose any points you like. But you really can choose any point you like. But the condition is, please do not choose weird points. Like, for example, Mr. Wong say any point, I choose this point. That's a horrible point to choose, right? You should choose something like here, where there's a clear indication, clear intersection of the coordinates. Okay? And it's easy to read. So rise over run. The rise is up. Now they are running to the left. What does that tell you about the value, the sign of the gradient? Positive or negative? Negative. So whatever it is, your answer better be negative. Or you can take y2 minus y1 over x2 minus x1. Or what's the easiest way to get a gradient? -5. No calculation required. The number, the coefficient of x is our gradient. So when it said find the gradient, you can say gradient equals to -5 without calculation. But what I want to talk about is explain the significance of the gradient. What is actually happening? This gradient is actually -5. Okay, so I'll write it over here. It tells us that every 1 minute, what happens to the temperature? Every plus 1 minute, what happens to the temperature? Go up or go down? Go down by how much? Every 1 minute, that means every time you move right by 1 cm, the y value drops down by how much? 5 degrees Celsius. So the significance, which is part C, it means the temperature decreases by 5 degrees Celsius per minute. Okay, so this is one accepted answer. The other accepted answer will be, you tell me it represents the rate of change of temperature. It's just like our distance and time. If I have a distance time graph, okay, I'll let you all copy this first. Good. Okay, so if I have a distance time graph like this, distance in meters, the time in minutes, every 1 minute, my distance increases by 10 meters. Another 1 minute, the distance increased by another 10 meters. So this over here, gradient, equals to 20 minus 10 is 10, divided by 1. 10 meters. Okay, the value is 10. It represents distance increase because it is sloping up by 10 meters per minute. 10 meters every minute. What does this unit over here sound like? Meters per minute. It is the unit for what? It starts with S. Speed. Meters per minute. Meters per second, kilometers per hour, distance divided by time. That is related to our gradient. Okay, so this is another possibility of a type of question that I can ask you. So you can explain it this way, or you can say the gradient represents the speed, which is 10 meters per minute. Okay? So this is it for our revision part 4.